Welcome back to this final section in part one of live sound reinforcement. As you know by now, a sound engineer wears a lot of different hats during the process of running a job. However, the job of mixing becomes the most important job of all when the lights go down. No matter how well the system is set up, if the engineer can't make it sound good, it's a wasted effort. So in this final section of part one, we're going to talk about some of the key ingredients that go into making a good mix. We asked several sound engineers what they felt was key to a good mix.
I think the most important part of mixing is having good gain control, so you have a nice balance between your attenuators and your faders.
In my opinion, the key to a good mix is balance.
Most engineers agree balance is the key to a good mix. So what do we mean by balance? When any one area of the audio spectrum from roughly 40 or 50 hertz on up to 16 kilohertz is missing to any great degree, we can describe the result as lacking fullness. Therefore, to a large degree, what most people regard as a pleasing mix contains a broad range of energy throughout the musical spectrum in some reasonable degree of balance. It's important to organize your mix. Label all your inputs and auxiliary and effect loops using masking tape and a marker. In low light, black ink on white masking tape makes it much easier to see where things are located. Typically, it's a good idea to keep all your effects grouped in one area, and all your instruments grouped that way as well. For example, keep all your drum channels in one location. One of the more important factors in achieving a clean, even mix is setting up a correct gain structure for all the inputs. Not only does this help prevent any one particular input from distorting the mixer's circuitry, but also ensures that the lowest possible noise level is achieved from each input. One common approach for doing this is to first adjust the input gain on the channel with the channel fader down. Then, while that channel is being used at the level it will be used during performance, increase the gain until the overload light begins to come on. Then, roll it back slightly until the overload light does not come on. Raise the fader to 0 dB. The meters on the mixer should now be peaking around 0 dB. Now, although musical mixes vary according to the type of music being played, as well as to your own artistic expression, let's talk about 4 ways to look at a typical music mix. First is the overall tonal quality of the music. This is a function not only of the mics and onboard EQ settings that are used, but also of how the main outboard EQ and crossover outputs are adjusted, as well as what proportion of the sound originates on stage. As the output level of the system is increased to the point where it begins to mask the onstage sounds, an increasing degree of control of the overall sound becomes possible at the mixer. As this happens, the tonal quality of the sound from on stage will become more dependent upon each channel's EQ, compression, and outboard effects. So it's important to understand what proportion of the actual output is coming from the stage versus the system and adjust the channel balances accordingly for the room. Here's the band playing without the support of the PA.
Guys, go ahead.
Now they'll play with the PA mains up. By having the majority of the signal from the stage coming through the PA, a processed, smoother, fuller, and more controllable sound can be achieved. This is because the output is being influenced to a much greater degree by the signal processing gear here at the mixer than at the stage. The second mix consideration is how the mix fits together and what it needs to stand out, in what way and at what time. One way to do this is to emphasize individual components of the mix in different frequency ranges. For example, you might slightly boost the kick drum in the 3K to 6K range, as well as the vocal in the 8K to 10K range, allowing them to stand out in the mix during a ballad. To demonstrate this, the band will play without the EQ emphasis and then with the EQ emphasis. First, without EQ.
Guys, can I hear a couple bars?
When I came home last night, she was 500 miles gone.
Now with EQ.
When I came home last night, Lord, she was 500 miles gone.
By adding EQ emphasis to certain instruments during certain songs, a mix can be made much more interesting. The third mix consideration is viewing the mix from a dynamic perspective. As we mentioned in the sound check segment, certain instruments such as bass and vocals have overly wide dynamic shifts. This can cause their output to be uneven and make it difficult to manage in the mix. Using separate compressors on these instruments helps smooth out their dynamic output and makes it easier to keep the mix under control. Noise gates, another dynamic device we talked about earlier, helps maintain a tight drum sound by reducing the amount of ring out after a drum has been hit. Compressors and noise gates go a long way towards smoothing out the sound of the mix, as well as making it easier for the engineer to control. The fourth mix consideration is the need to view the mix on a timeline, which we break up into short-term and long-term. In the short term, a typical mix needs to be filled out with delay and reverb. Reverb is commonly added to snare drum and vocals. Try using a short reverb time on songs with a quick pace and a longer reverb time for ballads and special effects.
Lights on, everybody. Won't you lend an ear? You know we came to party, and we can make it happen here, yeah.
Delay can also be used to create the illusion of a wider, deeper soundscape. Dave has set up a reverb and delay to demonstrate how these effects can really help fill out the sound of the mix. First, without effects.
Guys, could you play a couple bars?
When I came home last night, Lord, she was 500 miles gone.
Then, with the effect.
I said when I came home last night, she was 500 miles gone.
A good tip for using a delay is to sync the delay with the beat of the music. Dave, can you explain how you do that?
There's two methods. Some delays will have a tap button, which you can simply tap and it'll sync the delay with the time of the music. Or you can do it the manual way of dialing it up in milliseconds.
Synchronizing a delay with the beat of the music can give the music a more rhythmically cohesive feel. This is because the slapback of the delay can be synced with an offbeat of the tempo of the music. However, if your delay unit doesn't have a tap feature, you have two problems. One, how do you find the tempo of the song? And two, once you find the tempo, which is expressed as beats per minute, how do you convert it into milliseconds? The solution for number one is to purchase and have on hand a portable metronome with a tap capability, such as the Boss DB88, which can easily provide the beats per minute for whatever music you're listening to. Simply tap along with the music and the unit will display the tempo in beats per minute. For problem number two, here's the formula for converting beats per minute into milliseconds, where BPM is the tempo in beats per minute, and the time signature, or TS, is the numerator, or bottom number of the time signature. For example, the numerator in a 4/4 time signature is the bottom 4. Following this formula, if the BPM is 120 and the time signature is 4/4, then our formula would show 60 divided by 120 divided by 4 times 1000, or 2000 milliseconds per measure. This means at a tempo of 120 beats per minute, a delay setting of 2000 milliseconds would provide one slapback every 4 beats, or once per measure. Now that we know the delay time for one measure or one whole note, we can easily calculate the delay times for half notes, or 1 second, quarter notes, 500 milliseconds, and eighth notes, 250 milliseconds. One quick on-the-job solution for setting a delay time is to adjust the feedback setting on the delay unit to 50% and monitor yourself through the delay line while you mic check at a steady tempo. If the echoes occur too close together, lengthen the delay time. If the echoes are too far apart, shorten the delay time. Reverb and delay can really help fill the sound out, as well as add depth and dimension. As the mixer, you'll often be responsible for adjusting the inconsistencies made by the band as they play one song to the next. For example, the bassist may reduce his volume by a certain amount during a ballad, which may put the kick drum out in front of the rest of the mix. So one important job of the engineer is to ride gain on the faders and keep the mix in balance. However, the sound engineer's job is far from limited to just writing the faders. Here are some other ways the engineer can get involved with the performance. Develop a cue list for performance changes that can be made at the console during the show. For top 40 bands, this can make a real difference, especially since today's hit songs have very different studio effects. By working out the various effect presets ahead of time, the engineer can help each song sound closer to the original. Many bands pre-record backing tracks, such as extra vocals, keyboards, or percussion parts to help fill out the arrangement played by the band live. The engineer can set this process up by cueing the click track to the drummer and rolling the extra tracks into the mix smoothly and without noticeable lag time. If you as the engineer also happen to be a musician or singer, you can really add to what's going on stage as the invisible extra voice or a rhythm or solo player in arrangements, all while mixing the sound as well. This is simple to do and requires only an extra channel set up to accommodate the instrument or mic. What's even better is you get to use the entire PA system as your monitor. You can really augment the band's arrangements by using a computer-based MIDI sequencing program. With a MIDI system, a sound module is triggered by the MIDI sequencer software, and the outputs of the module are routed into the inputs of the mixer, where they can be controlled and balanced by the engineer. Running MIDI from a laptop requires some extra pieces of gear, such as a MIDI processor, software, and a sound module, but it can be well worth the investment. These are just a few ideas on how you can maximize your work behind the console. Well, this brings us to the end of part 1 of this show on live sound reinforcement. As I'm sure you've seen, the engineer's job is far more complex than most people realize. And to do it well means understanding some electronics, the nature of sound and audio, and a variety of different pieces of gear, as well as the art of equalization and musical balance. Hopefully, though, this program has provided you some useful information on those subjects that you can put to use immediately to help improve your own work. In part 2, we'll take you into the field and look firsthand at several sound reinforcement jobs in progress. We'll show you how real situations are handled by using many of the techniques we demonstrated in part 1. In live sound, no two jobs are the same. Each job brings its own set of environmental, acoustical, and musical challenges. However, the more problem-solving experience you develop, the more quickly you can get back to the essential job of making the band sound good and the audience glad they came. So, stay tuned. We'll be right back for part 2 of live sound reinforcement.